welcome to this video where I'm going to show you how to set up the simulation for the rocket design activity. And in this video what I'm going to show you is how to create a new Unity project from scratch, how to import the rocket simulation package into Unity, then I'm going to walk through how the rocket simulation works, and then I'm going to show you how you run simulations. So to start off with, we need to create a new Unity project, and we're going to do that by going to the Unity Hub application, which you should have installed as part of the general Unity installation. And from here what we're going to do is click on New Project. And the things I'm going to check on here are which Unity editor version it's on. And this one I've got a reasonable latest version of Unity, so a 2022. So the exact numbers there don't matter particularly, but you want to have a version that's at least 2022. The defaults here are fine. It's going to be a 3D project. And then crucially on this bit here, we've got settings here. We've got the project name and where it's going to be stored. So what I'm going to do here is put this somewhere sensible, to store it somewhere sensible under My Documents, and I'm just going to install it under Work. You can choose whatever you want to do. It needs to be somewhere where you can remember it, and it needs to be not on a network drive, so like a Dropbox drive that updates itself regularly. And then we can give it a name, so let's call it Rocket Simulation version 1. And it'll create a folder with that name in that directory. Okay, we're all good to go, so I'm going to hit Create Project, and Unity is going to trundle away for some time setting up the project, so it's got to bring in a lot of different files to get it to work. It only has to do this big job once at the beginning. Once it's done it once, it's much quicker to reopen the project. So let's let that get on with it. Okay, good. So Unity has created a blank project for me, and it's given me the name I gave it, so Rocket Simulation version 1, and there's just a sort of empty scene to start off with. Okay, so that's good. What we now need to do is upload the simulation package to this. So this is the thing that runs inside Unity, and what we're going to have to do first is download that from Blackboard, and click on Rocket Design Activity, and then Water Rocket Simulation Unity Package zip file. Click on that and it will download it. You can download it straight to your downloads folder, whatever. Just to save one step, I'm actually going to download it to where I have the project. So I set my project up in Work and Rocket Simulation version 1, and I'm just going to save it in there, so it just means when we unpack it, it will be one less step to do. Okay, so that's downloaded. It's fairly quick to download. So now what we have to do is unzip that file. So if we go to that directory, so it was in, I saved it in Work, Rocket Simulator version 1, and where is it? Right at the bottom there. So I'm just going to double click that to unzip it. It's asking me to buy it. I don't want to, so I'm just going to say no, and I'm just going to extract straight to the directory it's suggested, and that's just going to extract it all in that Work folder. Okay, and then we're done with the zip file. So we've unzipped the file. Now we need to import it into Unity, and to do that we're going to go to Window, Package Manager, and then when this other window opens we're going to go in the top left hand corner, little chevron by the plus, and then do Add Package from Disk. And then we need to find out where we unzipped it, so it's helpfully found out where I last was. So where you unzipped it, Water Rocket Simulation there, so that's the thing we unzipped. There's another level of directory. And then the key thing here is we need to click on this file package.json, and that's the script that allows all the files to come into the project. Okay, so I'm going to click open there. So Unity is now going to trundle along and bring all those things into the project. Okay, so we've got a warning coming out. This project is using the new input system package, but blah blah blah. The long and the short of it is we have to use the new input system, so we click on yes to that. Okay, and what happens now is it has to restart the editor for various reasons, but anyway, it's on an automatic restart, so it'll do that without you doing anything. And it's much quicker starting second time. Okay, we can close that window, we don't need it anymore. And it's saying error, package manager closed. We can forget that because that's just what we were doing there. So in fact, I'm just going to clear that error, so there's nothing there. Okay, so if it's all gone well, if you click on the project window and then scroll down all the way to the bottom, you should see something called Water Rocket Simulation in the long list of packages. And if you click on that and then click on Scenes, there should be a scene called Water Rocket. If you double click on that, little tiny water rocket will appear on your screen. So that means you've successfully set up the simulation. Okay, so what I'm now going to do is just kind of walk through the Unity environment in terms of all the different windows. It takes a little bit of a while getting used to how to move around. It's a bit like starting a new game or something. You have to get used to the way the keyboard works and the controls work, and it can feel a bit frustrating to start off with when you can't move around and do things, but hopefully you'll soon get used to it. So this window in the middle here is our scene view here, so this tab says scene, and this is kind of where you do all your editing work, and when you run the simulation, it will jump to the game window and you can see things going on in there. So first off, we can see a tiny little rocket. I'm going to zoom in towards it. So if you use the middle wheelie button on your mouse, you can zoom in. There we go, and there's a little prototype rocket sitting there. And if you want to have a look round it, what you have to do is click the Alt key and then the left mouse button, and then you can drag it around. And it just so happens actually the sun is coming from the other side in this setup, so it's actually nicer looking at your rocket from there. I assume it's going to be a sunny day when you're doing your launching. But if you move it round, you can get a different view of your rocket. Okay, that's good. The other windows we need to look at, if you go into here to the hierarchy window, and every time you see a little triangle here, this will basically unlock the next level of the hierarchy of different things. And what we're interested on here really is just this level here, the simulation configuration, and this little window that pops up here is called an inspector window, and what that does is gives us all the controls we need to change the design of the rocket and kind of launch settings and wind conditions and so on, and some simulation parameters. So to access those, if you click somewhere else, if you go into this hierarchy, click on simulation configuration, you can then change everything you need to on here. Okay, going back to simulation configuration, a number of options here. So in terms of test mode, we've got a number of different test modes, so free flight, wind tunnel, thrust test, drop test, and so on down there. And then we've got some design parameters here. And the way these work is you can just drag on them and slide them, or you can type in a number there and it will change it on the slider. And when you finish and you save your project, these will go back to your the settings you left it. The settings that the project starts with are kind of semi-random, but basically all the sliders are either in the middle or one end or at the other end. So these are not optimal values in any sense, they're just left somewhere in the middle, and one of your jobs as a designer is to investigate how these parameters affect the design of your rocket. Okay, let's just give it a go. What I'm going to do first, since I fiddle with various sliders, is just do update configuration, and what that does is it kind of reads all the settings you put on here and then changes the design of the rocket. And I guess one of the crucial things here, the first parameter you have to change is build quality, and this goes between 0 and 1, where 0 is kind of the worst build quality and 1 is the highest build quality. And in terms of student rockets, this parameter is the one you have most control over, but probably has the most determination on your success. And if we want to run it, click the play button up here. Okay, and we sort of got a launch, but the rocket sort of tipped over and didn't really do very much at all. So let's imagine now that we've built a slightly better rocket, so things are stuck on a bit straighter. Update the configuration. So let's have another go now. If we put it full build quality, update configuration, and then launch. Okay, that was slightly better. The rocket ran up straight and parachute came out, and you can see on here we've got a height of around 14 meters and a flight time of about 5.5 seconds. Okay, and just in terms of navigating here, the default camera you're on is a kind of orbit cam. So imagine that this is like a drone following your rocket. So it goes up and down with the rocket, and you can kind of orbit round, and you can use the wheelie mouse to go in and out. So that's quite good for getting sort of close-up views of what's going on with the parachute. But just to give an illustration, for some other views, if you go to cameras and you do a look at camera, so I've selected that, you can see it's grayed out, that's the kind of preview, but what I have to do is here's tick this to enable it, and what that will do now is the camera it will use will be this one. So let's have another go at that one, but this time with a fixed ground camera looking at it. So this is a bit like you on launch day looking at your rocket. This is what it will look like, hopefully. And there we go, straight up, straight down, 5.5 seconds there on the clock. Okay, that's good. So what else can we change? If we go back to the simulation configuration, we look to build quality. You can do things like change the length of the nose, you can change the size of the parachute, we can, let's make the fins a bit smaller, update configuration, and let's make put the fins down a bit, too far, move it up a bit. Okay, that's cool. And we can do things like change the amount of water in, we can increase the pressure a bit, we can change the launch angle if we want, update the configuration, and let's just try that. Okay, that was a pretty clean separation of the parachute. Went up to 17 meters. Flight time 6.5 seconds. Okay, so that was interesting. What we can do is add some wind, and quite often for launches it is pretty windy. We've done it in up to 10 meters a second wind before. I won't put that on full. So if we include that, and the wind's just coming from the side, and now if we run that, you can see these arrows up in the sky, and those are the wind. So that wind is affecting our X. You can see our rocket sort of took off into wind, but it's actually now blowing back in the wind. And on launch day, we will be able to alter the angle of the rocket to try and keep it within the launch area. So we may re-angle it up to sort of 10-15 degrees to try and keep it in the launch area. So when you're designing your rocket and any nose cones, it must be stable enough on the launch pad that nothing falls off when the rocket is tipped over. Okay, let's look at some of the other test modes we can use. So on test mode, we're on free flight there. If we now go to wind tunnel test to update configuration, and then press play. So we've got a wind speed of 5 meters a second coming from right to left, and we can see our rocket is just about stable. It's kind of pointing into the wind, and these arrows, which you probably noticed, the red arrows are drag, The green arrow is a lift, and the blue arrow is the wind, oncoming wind. So this is tell you where the wind is coming from. So drag and lift. And what we can do is change the direction of the wind by changing the, so this is a bit like a wind tunnel where you can change the direction. So effectively you can put a gust into the flow coming from one side to the other, and we can see how the rocket points into the wind. So the thing of interest is what the fins do. So let's try increasing the fin area. I'm going to do update configuration. Doesn't always work when you try and do it dynamically. We've now got bigger fins, and what we can do now, if we see what happens, it kind of changes the way the thing responds to the wind. And if we make the fins really small, the thing you notice now is that the rocket is only very weakly stable, so it tends to kind of oscillate. And so when you launch rockets with very, very small fins on, or no fins, or unstable, they tend to sort of wallow all over the place. And if we increase the fin area but then move the fins up by sliding that, fins are now on the front, and the rocket actually turns around in flight. So surprise, surprise, if you put your stabilizing fins on the front of your rocket, it flips over, and pretty much that's game over for any rocket if it flips over in flight. Drag goes up enormously, your nose cone's probably going to get ripped off and so on. So one of the challenges is getting fins that are just big enough to make it stable, and no more, but sufficient that it does stay pointing into the wind. And the trick is choosing the fins at about the right size, and there's no prizes for having big fins. If your fins are too big, it's more drag, and if the rocket is very, very stable, it tends to point straight into the wind, and you get funny effects where it just flies sideways. If we click the, I tell you what, let's put these fins back where they want to. So then that will now flip round, and we can do enable turbulence. So what this is now doing is basically making the wind vary in time. So you can see there, this is if imagine your rocket was going up on a gusty day, this is how it would respond in flight. So it kind of wobble all over the place, and you want it to sort of point into the wind, but if it's too stable it points into every gust and tends to fly all over the place. If we increase the wind speed, what you notice now is actually the frequency of which the thing responds is much faster, so it tends to respond in direction much faster when the wind speed is faster. Okay, that's good. Okay, so let's try out the next test mode. That is the thrust test. Just do update configuration, and what this is going to do is simulate a test of the rocket just fixed on a launch pad, so you can measure the thrust. So you notice there that you can see the centre of gravity go up, and that's because as you're using the water, the centre of gravity of the rocket is moving upwards. We could see the some sort of visualization of the water coming out. What we really want to do is see how the thrust varies with time. There's another video on using this in more detail, but if you do Control G for grapher, a window should open. You can drag it to make it the size that you want it. You want to make sure that you can see things and it's expanded out. And actually we're not going to save these, so I'm going to turn that off. So now if I press stop and then run it again, you should see a plot of thrust against time. So there we go, thrust came on, got about 40 odd newtons, then it came up and then dropped off. So for example, if you did want to record that, if you hit the record button, run it again. Okay, and then you can do show in Explorer. You find the Excel file is just saved, and then if you want to have a look at that in Excel, you can select them, insert, recommended chart, and Let's have an XY scatter with lines on it. That will do. And there we go, there's our thrust against time. So the launch happened at 2 seconds, and we got around 40 newtons to start off with, and then for about 3/4 of a second the thrust dropped off, and then it went down to 0. Okay, so what's next? Let's do a drop test, do update configuration. And I've also noticed that our look-at camera is still on, so this one we want the camera to follow the thing as it's dropped, so I'm going to turn that off, so then it should jump to the right camera. And let's give that a whirl. Okay, so we're now kind of following the drone, following the rocket as it's falling with the drone, and we can see the parachute come out, and there we can see the vertical velocity. It's accelerated now with gravity, the parachute comes out, and then this is its terminal velocity here, so you can read that off there to see what the terminal velocity is for your parachute. And you can, if we go back to the simulation configuration, you can try out a different parachute size. So let's make a big parachute, update configuration, run it again. And there we go, we've got a much bigger parachute. It's taken quite a lot longer to come out, but our descent velocity is quite a lot lower. Okay, one last parameter which I haven't shown you yet is this slow motion factor, and so far we've been having it at about half speed, so we can see what's going on. If we go up to full speed, this is what it looked like in real life, so things happen real quickly. Rockets up and down. I'll make the parachute diameter a bit smaller. And if we now make it run at slower speed, update configuration, so we're now going at about 10% speed. It gives you more of a chance to see what's going on. You can see some of the gory details of what's going on in the flow physics. We've got a crosswind on the launch there, so you can see there's actually side forces on the fins, and that's causing it to point into the wind. Our nose cone has come off, our parachute is deployed, and it's started to come out. It's slowing the rocket down, things tipping over. In real life the fins get snagged on the parachute lines. It's really frustrating, but if that happened in real life, probably your parachute would have got snagged in your fins. There's another reason for having your fins far back and not too big, but as you can see, there's a lot of very complicated things going on there, and your job is to try and kind of simplify that as much as possible so your parachute has got the best chance of coming out. Okay, and then so getting the best out of this simulation, there's loads of parameters here to vary. You can't really optimize your rocket just by fiddling with these variables, but what you can do with the simulation is understand how sensitive your flight times are to these different parameters. So the suggestion is that you pick a nominal value of build quality, so not either the best or the worst, somewhere in the middle, and that'll be realistic because your rocket won't be completely straight and the egg won't be exactly on the center of gravity, so the center line, so things will be slightly offset. And then you can vary these parameters, see what a big parachute, little parachute difference, what difference that makes. The fins obviously affects the stability. Just look at that in the wind tunnel mode, so that you need to get it so it's stable, but only just stable enough. You don't want it really stable. The launch settings, pretty much, you can vary the water fraction, that's an important one. The launch pressure will be fixed on launch day depending on how windy it is. The maximum pressure we can go to is 10, but it'll be up there somewhere. The launch elevation angle, depending on how windy it is, we might have this thing knocked back to 85 degrees or 80 degrees, so probably best to look at it when you're optimizing as such. Don't do it with the thing completely vertical. And then wind, as I say, last year it was really windy, but there's probably going to be some wind, so look at it in the middle there. And I would probably leave the turbulence on because that's realistic in that it's going to be, it's probably going to be gusty on the day. Okay, so that's the rocket simulation. It's here to guide your engineering intuition so that when you sit down building your rocket in the lab and you're making these decisions, and well, you've used your Excel spreadsheet to work things out, you've got some dynamics from this, and so what this simulation allows you to do is lots and lots of what if tests. On the day, will there be a little bit of luck? Probably. In fact, an engineering student last year said the opposite of engineering is luck, and he said the thing he learned from this activity is that by doing engineering, you reduced your reliance on luck for things to happen. So to get everything to work, there's a lot of mechanical engineering that goes into making joints and everything else, sticking things on straight. There's a bit of thinking about how you're going to deploy a parachute, but overall it's about making a balanced decision between all these different parameters that you've got, so you've got the best chance of getting a really good flight time on launch day.